Okay, we're going to talk about hemostasis now in this video. So this is the process of stopping blood or blood clotting. So there are 3 steps, but we're going to talk about all 5 steps that actually occur during this entire process. Okay, so we have vascular spasm, platelet plug formation, coagulation, which is blood clotting, then we have clot retraction, and then fibrinolysis. Okay, so we will start with vascular spasm. Okay, so let's look at our purple, I guess, our vessel here. Okay, so we have our endothelial cells on either side. Let's draw this kind of big. And say we have a break in these, right? Because we have an injury. And these all have nuclei, of course. I need to make this larger, make this faster. Okay, so these are our endothelial cells that line our blood vessels. Okay, underneath that we have our collagen fibers. Okay, so our collagen fibers, and then we have our smooth muscle. Let me erase this stuff up here so we have more room for this. Okay. All right. So here we have our smooth muscle. Okay. All right, so here's our blood vessel that is damaged. Okay. So if this could be triggered in a number of different ways. If we have direct injury to our the smooth muscle in this layer here, okay, that could trigger a vascular spasm. These endothelial cells can also release endothelin. Okay, this will bind to receptors on the smooth muscle and tell it to contract, which would pull everything inward like this. Okay, or there's something known as a myogenic mechanism if the smooth muscle is injured, and that will cause contraction as well. Okay, we have these pain receptors, these nociceptors. Okay, here's our nociceptor there, pain receptor. And these could become activated as well due to inflammatory chemicals that would happen, that would come to a site of injury like this, known as prostaglandins, and those basophils will come to the site too. And this can also cause contraction. So those are all the ways that we can get a vascular spasm to start. Okay. So pretty simple. Vascular spasm is trying to close this site of injury as much as possible so that blood doesn't just escape, right? We don't want that. Okay. Then we have platelet plug formation. Okay, so platelets want to bind to collagen fibers. They don't bind to these endothelial cells. Okay, so once these are exposed, right here, now the platelets can bind. So we have platelets throughout our blood here, and they're just going to flow through until there's some sort of damage that exposes those collagen fibers. Okay, so there's a receptor on this platelet known as, I'll just draw it here, von Willebrand factor, and this helps to stabilize platelet binding to collagen. Okay, so how it sticks to collagen. So when it's activated, the platelets swell, so they become larger and they become spiky. So they look more like this. Okay, they're going to go to this site here and start to build up. Okay, so they're binding to the collagen, then they bind to each other. Okay, ADP will cause more platelets to stick and to release their contents. Serotonin and thromboxane A2 will enhance that vascular spasm from step 1, okay, by binding to the smooth muscle and causing contraction, and they will help out with platelet aggregation. There's a glycoprotein in the cell membrane of, or plasma membrane of the platelets, glycoprotein 3A and 2B, and these help to link the platelets together. Okay, so let's say these proteins are here, and they help link the different platelets to each other. Okay, oops, this has more, and then the link. Okay, and then they'll start to form more and more. So again, this is a positive feedback system because we get more and more platelets here. Okay, now we have our platelet plug, right? It's plugged up with platelets, so now blood is not seeping out of the blood vessel. Okay, and then we have coagulation, which has a lot of different steps to it, okay? So first we have factor 12. So there's going to be a negative charges all surrounding these platelets, okay? Let me erase some of this other stuff we have going on here so that we can just concentrate on coagulation now. Okay, let's do a different color too. We'll start with blue. Okay, so these proteins are all made in the liver that I'm going to discuss now. Factor 12, okay, is going to interact with these negative charges on the platelet plug to become activated. And this also activates factor 11. Okay, factor 11. This activates factor 9. Okay. And then factor 9 will interact with factor 8. Okay, and they form a complex using calcium and platelet factor 3, PF3. These together will turn the inactive form of factor 10 to the activated form. Okay, this active form reacts with factor 5, platelet factor 3, and calcium. Okay, so that's involved here. Calcium again are used, okay, to activate a prothrombin activator. Okay, this along with factor 2, or we're just going to draw the Roman numerals here. Factor 2 converts prothrombin to the active, I'm just going to put PT for prothrombin, to the active thrombin. Okay, so it's all factor 2. Now, what thrombin does is it links fibrinogen together to form fibrin. So here's our fibrinogen linking together to form fibrin. So a long fiber. Okay, this is insoluble in blood plasma, so it's going to stay as this long fiber. So now blood is becoming more gel-like than liquid, and it's going to flow a lot more slowly. Thrombin will also interact with factor 13. Okay, and along with calcium, this will activate, okay? And now factor 13 can cross-link these fibrin strands. So now we have cross-linking, so we're gonna have more of like a mesh going on here. Okay, so now here we have our fibrin mesh network. Okay, now this can go and lay over the clot. Okay, so we're gonna have like these, let me draw this a little bit thicker. These fibrin strands laying over the clot and helping to keep it in place. We don't want this clot coming off and floating within the bloodstream, right? That could be very dangerous. So we need this fibrin mesh network, okay? So that was all the intrinsic pathway, okay? So what's happening in the blood independent of the clot? Again, this is triggered by those negative charges on the outside of the platelet plug, okay? So as a summary, we have factor 12 activating factor 11, factor 9, and then 8 activating X, factor 10. Okay, and then making that become active. Then we have our extrinsic pathway. Okay, extrinsic, I'll just draw it down here. So extrinsic, when there's tissue damage, the tissue is going to release factor 3. Okay, this will react with factor 7 in the blood, and that becomes active. This activated factor 7 can then activate factor 9 and 10. Okay, and this is much faster, right? A lot less steps here. Okay. So let's review one more time. The intrinsic pathway, it both leads to the same thing here. Okay, activation of factor 10. Okay, so we have factor, I'll write it in regular numbers to make it a little bit less confusing. For our intrinsic pathway, factor 12, 11, 9, 8, 10. Okay, and then our intrinsic, we have 3, 7, 10. Okay. Okay. And then we have, after we get from factor 10, we have factor 5 and 2. Okay. So a way, okay, so let's talk about a way to remember this. Okay. So way to remember this is, oh, and then, sorry, I'm missing one thing. We have factor 1 here as well, which is fibrinogen. I don't know if I mentioned that. Fibrinogen. Okay, so that's what links together to form that mesh network. Okay, so this is factor 10, right? So a way to remember this is we have everything here, right, from 12 to 8 except 10, because 10's down here. Okay, so 12, 11, 9, and 8. Here, 7 plus 3 equals 10. Okay, so we have our factor 10. And then here, 5 times 2 times 1 equals 10. Okay, so both, this is our intrinsic pathway and our extrinsic pathway, and they both lead to factor 10 and then to this pathway here to forming that fibrin mesh. Okay. Okay, and then finally clot retraction and fibrinolysis. So actin myosin within the platelet is going to contract. So within our little platelet here, it's going to contract within 30 to 60 minutes. This will pull on the fibrin strands, squeezing the serum from the clot. So serum is going to be released. Okay, so it's the plasma minus all the proteins. Okay, that's going to help draw our blood vessel together. Okay, so it's going to be drawn further together. Okay, then we have platelet-derived growth factor, PDGF. This is also released by the platelets. And this stimulates division of smooth muscle cells and fibroblasts. So fibroblasts are going to repair collagen fibers, if you remember from AMP1 from histology. Fibroblasts are what create those collagen fibers, okay? And smooth muscle cells are going to undergo mitosis, okay, due to PDGF. VEGF, vascular endothelial growth factor, is going to stimulate the endothelial cells to multiply and restore that endothelial lining. So mitotic division of the endothelial cells. Okay, so that's all clot retraction. Very simple. And then finally, fibrinolysis. Okay, so this is where the clot is going to be removed. Okay, so after this repair here is complete, that clot needs to be removed because we don't want it to keep getting platelets stuck to it and it gets bigger and bigger and bigger and then we don't have any more blood flow. Okay, so we need tissue plasminogen activator, TPA, and plasminogen. These are going to react and get converted to plasmin. This digests fibrin. Okay. Digest fibrin, fibrinogen, and D-dimer are released. So we have our fibrinogen, D-dimer. Okay, so now everything's digested, our clot is gone, our vessel is healed.